Okay, let's go through this example. There's something we have to understand and learn from here, which you're going to use a lot. Let's go and understand. Says the heights of 5 plants are measured and recorded below. All values are in centimeters. So we have these heights of 5 plants. All right. Remember, it's not always important to understand a question. The first part of a question. Let's go. Find the mean height and standard deviation. So we have these things, and they want the mean height. Well, that is a walk in the park. Anybody can get it. There is no frequency distribution here. There's no table, so we know the mean to use is the first one in our MF19. I'm sure most of you understand how to do it. I'm just going to put it. X bar is equal to the summation of x over n. That's the mean we use. If you're not sure, you can go back to the previous videos. You see how you get the mean. Now, either way, now that you do, let's put the sum over the number of terms. So how many do we have? 1, 2, 3, 4, 5. We have 5. Okay, so it's going to be 25.4 plus 26.1 plus 24.8 plus 27.2 plus 25.9. Okay, plus 25.9. all over 5. Okay, so we're going to divide this by 5. And what would we get as our mean now? We would say, let me add it. I would say 25.4 plus, did I have 25? Okay, 25.4 plus 26.1 plus 24.8 plus 27.2 plus 25.9. I get an answer, then divided by 5. I'll get 25.88. This is going to be my mean. Okay, 25.88 centimeters. Easy peasy lemon squeezy. Oh, they want standard deviation as well, so let's go ahead. Standard deviation is equal to the square root of the summation of x squared over n minus the mean squared. So this becomes summation of x squared. Will be squaring everything, right? So I'm going to say 25.4 squared. I know I could do it in a table, but I'm just going to do it here. Plus 26.1 squared plus 24.8 squared. I want to get the summation of x squared. Oh, should I do it in a table? Maybe let me just do it in a table. It's fine. This is my standard deviation formula. I'm coming back to you guys. So this is x, then here it will be my x squared. So let's put our x 25.4, 26.1, 24.8. I can still put it horizontally if you want space. I could say x, then x squared. Okay, 25.4. The other one is 26.1. The other one is 24.8. The other one is 27.2. Then the other one is 25.9. Now I square all that. So 25.4 squared becomes 645.16. So this becomes this becomes 645.16. Then the next one is 26.1 squared again. This becomes 681.21. So this becomes 681.21. Then 24.8 squared. This becomes 615.04. Now it'll be 27.2 squared, giving us 739.84. Okay, 739.84. Then 25.9 all squared now gives us 670.81. Okay, so 670.81. So now that we have these values, what's next? Well, remember that we are trying to find the standard deviation. So we should then have summation of x squared. What is this going to be? It's going to be 645.16 plus 681.21 plus 615.04 plus 739.84 plus 670.0.81 27.81 plus, no, it's everything. It's everything. So that's it. We get this answer, and that is going to be 3,352.06. So if I'm to make my table, it should look something like this. Then here. Then this gets up to there. Could have it like this. Okay. So here are our columns. Okay. Then there is nothing over here. Then we are done. This is it. So once you have this, then you have your table. Either way, now we are done with this. There's nothing in this box. So we're done. Now we can find our standard deviation. We'd say then the standard deviation is equal to the square root of the summation of x squared over n minus the mean squared. What is it going to be? It's going to be the square root of, what's the summation? 3,352.06 divided by, how many terms did we have? 5. Okay, 5 plants minus, what did we get as our mean? 25.88. So minus 25.88 all squared, right? That's why it's never a good idea to put the square root sign first. Now here it is. This was the we've put our square root sign to cover everything. Make sure it does cover everything. So we would now say 3,352 divided by 0.06 divided by 5, and we get an answer. Then we say minus, open bracket, 25.88 squared, close. I get an answer. Then I'll say square root of that. Oh my gosh, my standard deviation is 0.798. Okay, so which is like, yeah, that's it, 0.798. That's what I get as my standard deviation. Okay, now, all right, so here, all these are the solutions for mean and standard deviation. Now let's go to part 2. It says, it was later found out that the ruler used had a calibration error. Whoa. And all values were 1.5 centimeters less than the actual height. All values were 1.5 centimeters less than the actual height. What was the correct mean of the 5 plants? What was the correct mean of the 5 plants? So to get the correct mean, all values were 1.5 less than, so I'm going to add 1.5 to all of them so that I get the true thing. So I have 25.4 blah blah blah. So that means my new values would be, instead of 25.4, I'm adding 1.5. So 25.4 plus 1.5, I'll get 26.9. So here my values, my values will be 26.9. Then the other one, 26.1 plus 1.5 becomes 27.6. Then the next one, 24.8 plus 1.5 becomes 26.3, right? 27.2 plus 1.5, this one becomes 28.7. Then 25.9 plus 1.5 becomes 27.4. So now we have 27.4. These are our values. Now we can get the mean again. So I would say x bar is the summation of x over the number of terms, which becomes 26.9 plus 27.6 plus 26.3 plus 28.7 plus 27.4, all divided by 5. 1, 2, 3, 4, 5. So yeah, we're 27.4. I'm adding them now, plus 26.3 plus 26 plus I get 136.9 divided by 5. I'll get my new mean being 27.38. This becomes my new mean, 27.38 centimeters. That's it. This is my standard deviation again in centimeters. Now, let's see. What was the part B? What was the correct mean of the 5 plants? Then what was the correct standard deviation of the 5 plants? So now I'll do part B. This is A. B, to get the new standard deviation, I'll just need to make my table first. X, then x squared. What are my x values? We can do it going down now, or we can still do it going sideways. So it just depends with if you have space. If you've got space, you can do it going down. X, then x squared, to say 26.9, 27.6, 26.3, 28.7, then 27.4. Then x squared now would say 26.9 squared becomes 723.61. In here, I would say 27.6 squared. This becomes 761.76. Then 26.3 squared becomes 691.69. Then 28.7 squared becomes 823.69. Then 27.4 squared becomes 750.76. Now I have my x squared values, and then I can now say the summation of x squared would be, that's the last thing I'd have. I'll say plus 3.69 plus 691.69 plus 761. Oh gosh, 761.76 plus 723.61. I would get 3,751.51. And here I have my values. So there we go. Here's my x squared. Let me do this, then this, then we have our table. Nice and easy, easy peasy, lemon squeezy, right? So there we go. We can have all the values in here. There we go. We can have all the values like that. All right, so here we have our values, and now we can say that standard deviation is equal to the square root of the summation of x squared over n minus the mean O squared, which becomes summation of x squared is 3751.51 over how many terms? 5, minus, what is the mean? 27.38. So minus 27.38 all squared, and we'll get the square root then. So we'll have 3751.51 divided by 5. We get an answer then, minus open bracket 27.38 squared, close bracket. Then I'll say square root of that. I'll get again 0.7984, blah blah blah. So I get 0.798. Here are my true answers, okay? And we are done. Now, there's something I want you to see, which is very important, which helps us to understand what we mean by coding. So coding is when you have done a measurement, right? And after doing a measurement, you find that there was a measurement error. There was some, we call it a systematic error. Then you now want to correct it, okay? You discover that you have a systematic error in your measurements, and you want to adjust your data. You want to fix it. So how do you do that? Let's see something. Let's compare our first mean to the second one. This is the mean, which had an error, but this was the first mean. 25.88 was the first mean. So 25, so mean 1 was 25.88 centimeters. What is the mean, the corrected mean? Corrected mean was 27.38 centimeters. So 27.38 centimeters. Now, what do we get if we are to subtract the second mean from the first one? So let's do that. Let's say mean 2 minus mean 1. What is it? 27.38 centimeters minus 25.88 centimeters. What would we get now? I'm going to punch that. I'd say 27.38 minus 25.88. I'll get 1.5. So I'll get 1.5 centimeters. And 1.5 centimeters is the correction which we did, because we found out that they were 1.5 centimeters less. So what we are seeing is that the mean, just like the values, is 1.5 centimeters different. So that means if you have original data, and you've been told that your values were 1.5 centimeters less, and they then tell you, find the new mean. All the values were 1.5 centimeters less. Find the new mean. Mean 2 would just be equal to the old mean plus the error plus the 1.5. Then you'd be able to get it. So that means if you want a mean after a correction, after some correction, what you do is you check the old mean, you get the old mean, then you just add your correction to it, or remove the correction factor to the original mean. So here we were told that all the values were 1.5 less. So to go to the new one, we had to add. So you'd be saying, so it's like we say that new mean, okay, the new mean, we can say mean new is equal to old mean, or mean original, okay, original mean, plus or minus the correction, okay, plus or minus the correction factor, depending on whatever has happened. If the values were less than, then you need to add the correction factor. If the values were too big, then you need to remove that correction factor. Now, for the cases which you are going to get, the values will be small. The values will be small. So what they show you is that you have a mean that is going to be, we have a mean of values that are less than, okay? So we'll be saying that your values are less than by some constant, and we could call this constant A. Okay, maybe before we do that, let me just speak one more thing about the standard deviation. Look at the standard deviation. What is the original standard deviation? 0.798, right? What is the new standard deviation? Where is it at? Here, standard deviation number 2 is again 0.798 centimeters. So is the standard deviation changed? No, the standard deviation is the same. So standard deviation is a measure of spread. And one thing you should know is that measures of spread are not affected by you shifting all the values by a constant. So it's like all the values were 1.5 less. Our new values will be 1.5 more. So all the new values, we're going to add 1.5 to them, right? If we do that to all values, that means it's not going to affect your standard deviation. Your standard deviation will remain the same. So standard deviation is not affected by the shift, by the coding. So what we mean by coding is to correct. Coding is when we correct every single term after we found that we have an error. So now here's what you're going to know. What you'll be having is you get some data, and we'll say it is x minus a. So you get a data that we call x minus a. The reason we'll call it x minus a is, like I said, we'll be just trying to say that the value, the original data, is actually smaller than what it should be. So it is an x minus a. The true value is going to be x. So you have an original value of that is actually smaller than. So what you do is then you'll be having to find, then they'll say find corrected mean, okay? Find the corrected mean. So what should you do? Find corrected mean and let's say find corrected mean and standard deviation. The corrected value. So what do you do to find them when you have something like this? When you have x minus a, what does it mean again? It means that the data you have is a less than what it should be. We have found out that your data is, so it's like for our case, we would have said our data is x minus 1.5 because they said that we found our data is 1.5 less than. they'll say that the mean for x minus 1.5 is this, blah, blah, blah. So what you do is, here are the steps. To find mean, to find corrected mean, here's how you do. To find corrected mean, what you simply do is, you find mean, first step is, you find mean of x minus a. Okay, that's step number one. Step number one, find mean of x minus a. Then step number two, add a to the mean of x minus a. Then you'll be having your new mean, because new mean is just original mean, which is mean of x minus a. Then you add your correction factor. So you now add a, because a is the correction factor, the value which is the thing. Okay, then you'll be done. Now for standard deviation, what is it? You just say standard deviation for corrected standard deviation. To get, here's how you get the corrected standard deviation. What do I do to get the corrected standard deviation? Easy peasy. Step one, get standard deviation of the original, which has an error. Standard deviation, get standard deviation of x minus a. Then step two, the standard deviation of x is the same as that of x minus a. Done. So the standard deviation won't change. You just get the standard deviation of x minus a, and you use that value for the standard deviation of x. Then you're done, and this is it. Bye for now. See you in the next video.